library. So, okay. The fourth one is the model library, and this is a server that's hosted by Oasis, where all of the models that are ready to deploy into a production system sit. So this is probably the destination for your model assets. So how do those four components fit together in our little ecosystem? This diagram kind of shows the different use cases. In the middle, you've got the model library, which is the server in the cloud, which holds all those model data assets. And then at the top, you've got the model developer who uses the model development toolkit to build and test the model. And then from there, they can publish the model to the model library. And down below, it shows two use cases for the end user of the models. They can use the user interface itself, or they can integrate the platform into their enterprise risk system. So there's two main use cases for the end user. But we're kind of concerned with the top part of the diagram, which is actually getting the model into the model library. So the central model asset, if you like, is a repository, and that is a collection of data, metadata, and code, which describes an Oasis model. And the structure of the repository is specific for use either in the Oasis platform or in the MDK. To summarize the data, there's two main types of data: the model data, which is the events, the footprints, the vulnerability, damageability functions. And that's what I'm going to be talking about in part 2. And that is eventually becomes a binary format. You start from a CSV format and then you convert it to a binary format. And that compresses it and makes it a bit smaller. The second type of data is keys data, which is reference data, which describes the model data. And also it does perform a function in the platform, which I'll explain later. But there are basically two folders of data that need to be provided. The metadata is descriptive information about the model name, the supplier name, i.e. your organization name, any model-specific parameters, and the internal file paths within that model repository. There is some code that needs to be provided, and that's currently Python code. And this code defines what exposure data is needed to run the model and how that exposure data, so locations, map into the model's dimensions. And that's something that I will illustrate a bit later as well. Just a practical point, although this encompasses the package, in practice, model data does not sit in the repository because the repository is more designed for source code and small files. So there's about 100 megabyte limit in GitHub, for example. And so typically, once your model is ready to go, you'll put your model data, the big files, on the Oasis model library, and the repository will be somewhere else. So here's an example of what the repository looks like. This is our Paris windstorm model, which is a repository in GitHub. All of our source code is in GitHub, and also some of our toy models are in GitHub. So you can see there, the repository name is Paris windstorm model, and you can see the folder structure has the key folders that we need to populate as model developers. There's the keys data, the metadata, the model data, and the source code sits in the SRC folder. So that's kind of what we need to target, and that's where we're trying to get to when we build a model in Oasis. In terms of the development process, what you'll probably do is develop locally on your machine, and you'll have your data there, you will have your repository there, and you will install the MDK, the Model Development Toolkit, and use that to test, refine the model. And when you're happy with it, when it's finished, you will then push the model data via SFTP to the Oasis model library. And you will put your model repository, which is everything but the big model data, somewhere like GitHub. GitHub allows you to have private repositories so it can be secure, but this is only one choice of a cloud hosted repository. So really you can put it anywhere as long as you can give access to it to somebody who wants to use your model. But most of our models are held in private GitHub repositories. So this is the last slide in the section. So I just wanted to give you my thinking on what the main steps are of the process of putting models into Oasis. So that would be create the model repository, prepare the model data, and that's the subject of the next section. Write the code using examples and templates. So this is a tricky area, and we do have lots of templates and examples to help you. And we're also available as a support desk essentially for this as well. So you're not on your own, but it is a bit tricky and a bit involved. The fourth step is testing the model. So you would install the model development toolkit and test it. And you might find that you need to refine the model, make some changes, because if you're starting from an existing model, you may need to ensure that the Oasis version of it produces the same results to an order of magnitude. And you may find that you need to adjust your model. And so refining and retesting is part of the process. And then finally, once you're happy with it, you would then push the data to the Oasis model library. So hopefully that gives you the context of what you need to do to get models into Oasis. And I'm now going to talk about the more conceptual aspects and the more detailed file formats of models.
Jo,
yes.
Just before you move on, I have just two quick questions. We obviously have had lots, well, you in particular, have had lots of experience of people in various stages of their models with a goal and objective, get them to Oasis. Of all of these steps here, where do you think that people make mistakes is not quite the right phrase, but they've made assumptions of what they could do and what we need to do and everything else. And where do you think people are not thinking enough about the challenges of doing this, and where they should ask for help, if you think there's a pattern at all?
I would say definitely in preparation for model data. There isn't one way of doing it, especially when you consider uncertainty and how to represent it. So I would say definitely get advice on step 2, and don't just consider one method. The first thing that you think of, when you get it, you go, oh, okay, and then you do something. But there may be other ways, right? And there may be better ways you can represent uncertainty, for example. So I'd say definitely get in touch when it comes to preparing the model data. And also in refining it, because that's part of the process of designing the model. And I guess the kind of tricky area is the number 3, which is writing the code, which maps exposures to models. But we have done a lot in that area in the last 3 months. We've just released a new version of the standard methodology and a template so that the model developer has less to do in terms of coding. It's really just using a template and extending it or amending it. So it's not as difficult as it used to be, and there will be lots of documentation coming out very soon on that new method.
Yeah, no, and I think to me, the message that I get back from talking to you and the rest of the team is sometimes, come to us earlier rather than later with what you think your process will be. Then we'll probably say, yep, go ahead, but watch these 2 steps, and then come back if you've got any problems. And obviously, we have some resources available to help with support, but good. And just one more thing, that was my question, but just everyone who's got any questions, I know there's quite a few people in the in this workshop, but do feel free to put stuff in the chat, and I certainly should be watching it, and Joe will try and do two things at once and do a bit of that as well. But back to you, Joe.
Okay, so that's the end of the first section on the whole process. The next section is on the Oasis model data itself. And to start with, I wanted to explain how we plug and play. Oasis is described as a plug and play loss modeling framework, meaning you could put in lots of different models from different vendors. And we've designed the agnostic model data standards to enable that. And no matter what the peril and region, model providers have freedom in how they define events and perils and geography and vulnerability. And the way that we have enabled that is by essentially separating the data into two categories. The core model data is keyed data, so it uses abstract keys, and the meaning of the keys are kept in separate files called key data or dictionaries. So every model in Oasis will look like the table on the left, the model data. It's integers and floating point numbers only. There's no strings, there's no text, there's no meaning. And all of the meaning is kept on the right, which is in the key data or dictionaries. So that is the way that we enable lots of different models to work in the same way within our kernel. And not only are the descriptions of the dimensions, the events, the areas different, but also the file formats may differ as well, depending on what the model dimensions are. And there will be more examples of that. But I just wanted to give that high level, this is how we achieve it. And this is what how we separate the data. So to start, let's have a high level look at what data plugs into Oasis. There's 3 data modules: exposures, which come from the end user, and the hazard and the vulnerability, which comprise the model. And these are 2 separate components because they can, in theory, be developed by different organizations, although you do need 2 compatible hazard and vulnerability modules to actually run a model in Oasis. This diagram breaks down into a little bit more detail in this diagram. Again, we've got the hazard module circle on the left and the vulnerability one on the right. Each of the boxes represents a file, and it's this is the set of core files that need to be provided. There's one file which sits in the middle and is required by both, which is the intensity bin dictionary. And this is required to be the same if you want to combine a hazard module from provider A with a vulnerability module from provider B. So that's what enables us to separate the modules essentially. But as long as it's a consistent set of data, then you can combine modules from different suppliers. So there's a mixture of Oasis model files here and dictionaries. And so let's just start, first of all, by talking about events and what they are. So an event is a data representation of a catastrophe. And it may be easy to define. It's normally not easy to define, but some perils lend themselves to easy definitions like named hurricanes, named storms, for example. You could have a catalogue of historical storms and that defines the event. But you do have to make decisions about what's the subset of data that I need to extract from my peril data set in order to represent that event. Where are the boundaries of intensity that I should consider? So this is a difficult thing to do. An event has to have a hazard footprint, and a hazard footprint defines the areas that are impacted by the event and the hazard intensity in each of those areas. So some examples of event catalogues that you commonly get in catastrophe models are historical event sets, so named storms over a certain period in time. Scenario events, so these are used by Lloyd's. They're realistic disaster scenarios. So they're not events that have happened, but they are key events that are of interest to model, such as a Cat 5 hurricane hitting Florida. These don't have to be associated with a timeline or a date, they're just scenarios. And commonly we do get stochastic event sets, and these are generated hypothetical event sets. And the reason that people go into stochastic event sets is because historical event sets tend to have gaps, geographical gaps. So if you want your model to be to cover a particular region, you need to really have events that affect that whole region in order to have a robust and useful model. So people do tend to try to develop stochastic events in order to give a really robust view of risk of a peril in a region. Finally, event occurrences. So events may be independent of time. You don't have to provide a timeline. But if you do provide a timeline of events, which is a file, another file that you provide with a set of files, then you can generate all sorts of time-based results like average annual loss and exceedance probability curves, which are the type of results that the insurance community needs to look at. So they can be just events, but more often than not, there will be event occurrences included in the model.
Joe, can I just a quick one? We have had not quite numbers, probably too much, but we've had some academic organizations in particular who think they knew what events really mean, but actually they're not really defined as we mean. And then we've also had, we've certainly done some on agriculture, for example, which aren't really the same type of events as the normal property cat stuff. And we've looked at one or two cyber things. Just any other thoughts on pitfalls or challenges on events in conceptually?
I think most people in the cat modeling community kind of know what they are, but it's very difficult for someone who just studies a particular peril in university, say, to really understand. The key concept to get is that it's not a hazard at a particular location. It's an event which impacts a whole area simultaneously at the same time. So it's just moving from the concept of a return period in a location independently to an event which impacts a whole area simultaneously, because it's the accumulation of losses which is important for the insurance industry. So it's just that shift in understanding.
Thank you.
Okay, so I've got an example model to walk through to explain the concepts and explain the model file structures. So this is a map of Paris. So let's consider this square, the geographical scope of the model. We don't care what happens outside. And we've got 3 events which affect different areas of Paris, okay? So those are their storm tracks, if you like. Now, as a model developer, we need to decide how to divide up our region into areas. And those are called area perils. So we divide them up into area perils. The reason why it's not just areas is because it may be peril specific. And we may not be just looking at wind, we may also be looking at flood. And you might want to divide up the bit differently for the different peril. You might need a higher resolution near the river, for example. So we call them area perils, but it's just a way of dividing up the geography. And so we've got 4 grids, and we overlay our events. And this represents the event footprint. So event 1 impacts area 1 and 2 slightly. Event 2 impacts area 1 and 2, and event 3 impacts area 3, and area 4 is not affected at all in this model. So what does that look like as Oasis model data. I'm going to start with the small tables before dealing with the beast in the middle. At the top, at the top, this is the area peril dictionary. So it's the descriptive table, keys data, and it describes what the area perils are, and it describes them by latitude, longitude. So this could be the centroid of the grid, for example. So it's just descriptive information which explains what area peril ID means. On the right, we also divide up the range of potential hazard values into bins. And so bin 1 is a hazard intensity of a wind speed of between 50 and 60 meters per second. Bin 2 is a wind speed of between 60 and 70, and bin 3, 70 to 80. So we take our range of potential hazard intensity values, and then we bin them, we put them in a bin. And finally, at the bottom, there's no descriptions, but this is a core model file, which is a list of event IDs, so events 1, 2, and 3. And that's all there is to it, to that file. So what this data represents then is, for each event, for each area, what the intensity is. And I just want to focus on the first 3 records of this table, because there's more than one possibility. There's a possibility, or probability, I should say, of intensity bin 1 of 10%, 0.1, of 2 of 20%, and 3 of 70%. So what that tells us is it's more likely that we'll see a wind speed of 70 to 80 meters per second. It's got a higher probability. And this is the way that we represent uncertainty in the hazard intensity. You don't have to. A lot of models have a single intensity bin per footprint, but there is a possibility to represent hazard uncertainty in this format. So that is a summary of all of the hazard files. And then we move on to the vulnerability side.
Joe, sorry to interrupt. Just there's a question that's, I'm trying to think of the right time to answer it, but now might be the right time. So the question says, but are the stochastic events still generated based on historical event sets, or what is the basis of this generation?
Can I take that at the end?
Yeah, sure.
Yeah, if you could remind me, that would be great.
I will.
So we'll just continue. So vulnerability is the damage response to a certain level of intensity, regardless of where it is. So that's how we separate vulnerability from hazard, is we say we don't care where it is, just give us the intensity and tell us what possible damage we could get and with what probability. So there's 2 simple vulnerability functions here. The top one is a brick house, and the second one is a straw house. And what this chart is telling us, if we just look at 2 of the bars, let's say this one, if you can see my mouse. For intensity bin 1, as defined on the previous slide, a wind speed of 50 to 60 miles an hour, there is a 90% chance of 0 to 40% damage, and a 10% chance of 40 to 100% damage, and so on. And that's defined for every single bin. And if you compare the 2, you can see that there's more red on the bottom chart. That means that there's a higher probability of worse damage, i.e. it's a more vulnerable structure to wind, being a straw house rather than a brick house. So this is the way we build our vulnerability functions. Hazard intensity is binned into those ranges, but also we bin damage as well. So in this case, we've got 2 bins, one of 0 to 40%, and a second one of 40 to 100%. So what this looks like as data, again, let's have a look at the smaller tables, the dictionaries first. First of all, the 2 vulnerabilities have associated construction codes, which represents the construction type, so brick and straw. And there are often different characteristics that vulnerability functions are broken down by. It can be occupancy type, i.e. residential, commercial, industrial. It can be the age of the building is a factor. So you could have the year built as a field. And for certain perils like earthquake, it's often broken down by the height of the building, how many stories there are. So these are what's called primary modifiers, the most common characteristics that people use to separate out different vulnerability types. We've got the intensity bin dictionary, which is the same as it was for the hazard. And down below is the damage bin dictionary, which discretizes damage. And this is relative damage, relative to the total value of the risk, the insured asset. So 0 to 40% and 40 to 100%. So the distributions of damage are kept in the vulnerability file in the middle. And let's just have a look at the first two records. This is telling us that for vulnerability ID 1, which is the brick house, and for intensity 1, which is 50 to 60 meters per second, we have the possibility of two levels of damage. Damage of bin 1, which is under 40%, a probability of 0.9, and damage bin 2, a probability of 10% of 40% damage or more. So you can see that the central table is a model abstract format, which just contains the numbers, the integers and the floats. And all of the meaningful information is held in the dictionaries, vulnerability, intensity, and damage. So to put them all together then, this is what it looks like. And you can see that it's the intensity bin dictionary which connects the hazard on the left with the vulnerability on the right. And there is one extra table that we haven't seen before, which is the occurrence file. And this is where events are assigned to a timeline, a year with a month and a date. So this is the file that's needed to explore uncertainty in event frequency. So it's commonly provided with the model files, but it doesn't need to be. Okay, so how is the model data used? How does the exposure data interact with the model data? Well, this is a set of data which represents locations which may be uploaded to a CAP modeling system to be analyzed. And there are 3 locations with latitude, longitude, construction code, and the TIV, the total insured value of the building, which is some currency value. The format of this is open exposure data, which is part of the open data standards. And this is the standard way to get exposure data into Oasis. And I think all of these sessions are being recorded. There is a session on that you can watch another time. So what happens when a user uploads the exposures to the platform and wants to run it against the model? Well, let's just plot those locations on our map. So the stars are where the locations are, 1, 2, and 3. And what happens in a data pre-processing step before the main model execution is that the exposures get sent to a keys lookup process. And the keys lookup process returns an area peril ID and a vulnerability ID for each location. And that is where it is. So location 1 is in area peril 1. And so on, and what vulnerability function is the most appropriate for each location. So it's either 1 or 2 in our example. So as long as the kernel receives this information about every exposure, then it knows how to join the hazard and the vulnerability data together to compute the damage distribution for every event and location, and to compute ground-up losses, insured losses, and ultimately the outputs. So this is a standard process for all models, regardless of how they define area, how they define vulnerability. But the method of assigning area peril and vulnerability does differ from model to model. That's an unfortunate thing that we can't do anything about. We can't change that variability. So this is where the code comes in. The code defines the logic for assigning the area peril and the vulnerability ID. How are we doing for time, Vicky?
You're not doing too bad, but actually that's hard to answer because I'm not quite sure how much you've got left. There are a couple of questions I think are pertinent for the last bit you've just done. Yeah. Do you want to, should we have a just quick look at them? You can tell me what you want to do. Yeah. I think I might have answered the stochastic events one, hopefully well enough. But what is the recommended number of bins to account for primary hazard uncertainty in terms of accuracy, processing time, trade-offs?
Okay, specifically on the hazard side.
That's what it says.
Right. First of all, reduce the range of values to a range which is meaningful for losses. So don't start from 0 meters per second, because that's not going to cause any damage. I would recommend starting with a few hundred bins, and then maybe consider less if you feel that's too high a resolution. There is definitely a trade-off between number of bins and file sizes, but it does seem that we can handle pretty big model files. So start fine resolution and then reduce if you find that it doesn't compromise the accuracy of the model.
I think, Joe, one thing that it's one of those things that's what part of the process in the model development toolkit, the MDK, that you can refine these things and test different options, right?
Yeah, that's right.
So it is a trade-off, and that trade-off is one you can't really specify it up front. You've got to be able to just go, well, let's try this and see what happens. We sometimes can advise a bit, I suppose.
Yes. But there isn't a great performance impact unless the model files are like terabytes. Because we do have an indexing method in model execution whereby we can access that data really quickly, even if on disk it's really big. So don't compromise the accuracy, assuming that the performance won't be there. Start with a nice fine resolution and then optimize it later.
One more quick question, I think. Where do the vulnerability functions come from? Are they already included in the peril model package in Oasis?
Yeah, so if you're a hazard modeler, then unfortunately, we don't have vulnerability functions and they have to be created. So we don't provide any sort of model data. I guess there are two main approaches to vulnerability function building. One is an engineering approach where you study the physical characteristics of buildings. And then the alternative way is by looking at claims histories and looking at an event and what the hazard was, and looking at the damage associated with that. So building them from empirical data. Unfortunately, that data is not readily available. It tends to sit with the insurance companies who have all that data. So this is a really tricky area, especially for a hazard modeler. We did a project last year to build the Bangladesh cyclone model, and we actually collaborated with an existing model developer who was able to provide a framework for building them, and then the hazard modeler just did that bit. So I think really we need to work together and in the community to help each other to build out the vulnerability side, if that's not our area of expertise.
23 minutes to go till it finishes, by the way, is no answer your question.
Okay, that's plenty of time.
All right, good. That's all right then.
And what was the first one? Are the stochastic events still generate best historical event sets? What is the basis for this generation? It really depends on the peril.
I think, Joe, look, I've had a go at answering that one.
Did you?
I think I might have done a reasonable job. Not as good as you, I'm sure.
Okay.
But let's come back to that if we've got time. I suggest it's probably better for you to make sure you cover the rest of your thing first.
Okay. I've actually nearly finished, so we're looking good for time, I think.
All right.
Okay. So this is the summary then of the model data files. So the model data files are fixed format, and initially you build them in CSV format and then convert them into a binary format. And that's a very specific binary format for the kernel. And the link here takes you to the page which describes the rules for these files and also explains how to convert them into binary format. So that's part of the process of creating the model data. And the key or required model files are events, which is just a list of event IDs, single column. The footprint, which is the events and the areas that are impacted, the hazard intensities and the probability if you have uncertainty. And this is the file that gets really, really big, especially where you have thousands of events and you might have millions of areas if you've got a really fine-grained model. So that's the file that gets really big. Vulnerability, so that's where you have your vulnerability type, and for each one you look at the intensity, and for every intensity you say what the damage is going to be or what the probability of damage is if you have an uncertainty distribution for that. The damage bin dictionary is it breaks down the increments of damage in the model. Again, you choose how fine-grained you want to go. I would suggest starting quite fine-grained, like 100 or 200 bins. And this is something that you can play with in your optimization. It's the only dictionary file which is actually a required kernel file. All the other dictionaries are reference data, which go in the keys data folder, but this is the only this is the only dictionary that does actually reside in the model data folder. And optionally, you can provide an occurrence file, which is the event IDs and the years in which they occur. That's optional. The keys data file summary. So the primary purpose of key data, specifically the area peril dictionary and the vulnerability dictionary, is to enable the exposures to be mapped into the model's keys as a pre-processing step in the user workflow. And the file format can vary. For example, we have CSV formats, and we're working on a Parquet example for one of our toy models, Pywind. There is a secondary purpose for key data. This is descriptive, describing the main dimensions of the model, the events, the areas, the vulnerabilities, intensity bins and damage bins. So it is important to include those to make sense of the model from the user's perspective. So when designing a model, so these are the key areas of consideration, the key questions. How will you define event? For the events, how do you define area? How fine-grained or high or low resolution will you go? Will you use grid points? Will you use grid cells? Maybe you'll use variable resolution grid cells or postcodes. And what's the overall geographical scope of the model? Is it all European countries, for example? What perils will you cover? So will it be just wind, or will it be wind and storm surge? Will it be flood, and so on? And for each peril, what's the measure of that peril? What's the unit? What range of values will you include? And how will you break them down into intervals? For vulnerability, how do you classify different functions? Will you use construction codes, occupancy codes, building height, whether the property has a basement? For a flood peril, that's quite a key one. So the characteristics, the modifiers will vary depending on what peril you're looking at. And finally, what's the interval of damage? And will you include a bin for 0 damage and 100% damage? That's quite important consideration, because you do get these models which don't allow for zero damage, and you get lots and lots of really, really tiny losses, and that's just not realistic. You can't see that in claims counts, for example. So consider how you construct your intervals of damage. And I thought it would be useful to give you the answers for a particular real model that's been developed over last year. This is a model which is on a free license. So it's hosted by Oasis for a free license. And it was a funded project in collaboration with the Met Office, the UK Met Office, and the Bangladesh University of Engineering Technology, who each provided a different component. So the events were the 12 historical cyclones affecting Bangladesh since 1991. The perils were wind speed, provided by the Met Office, and storm surge, provided by the Bangladesh University. The area definition for the footprints were 4.4 kilometer spaced grid points, defined by latitude, longitude for wind and storm surge, but also the university provided a second footprint, which was higher resolution. It was a 1.5 kilometer grid spaced points for storm surge. The hazard intensity was gust speed for wind between 0 and 110 meters per second, broken down into 1,000 bins. And for storm surge, a flood depth of between 0 and 20 meters was considered in variable sized intervals, in total 22 bins. Vulnerability was fairly simple. It was only a few, 8, maybe 12 or 15 functions only, and it covered only residential properties. It covered only the structure of the building. In developed nations, we tend to look at the contents as well, because that's insurance coverage, but this was more about the economic losses to the structures in Bangladesh. And it also used construction type that was prevalent in Bangladesh. And also you get different vulnerability types by peril as well. So storm surge damage response will be different to wind. And the damage bins were broken down into intervals of 2%. This was a first cut of the model. This was not a refined model, just to make that clear. I think 1,000 bins was a bit excessive for the hazard. And I definitely would have suggested starting a bit higher up on the wind speed scale, because you get a lot of bins which cause zero damage there. So this was really just a first cut model to learn about the model development process in Oasis and provide a free model for Bangladesh. So that's the end of that section. I've got just 3 slides on the kernel calculation, because that was mentioned in the session description. And I first wanted to recap about how uncertainties are represented in Oasis model data, because the Oasis calculation engine is simulating losses, taking account of all of the uncertainties in the model. And if you don't have uncertainty, there's really nothing to do. It's just a deterministic model where you could just look it up from a table. So using Oasis is really about exploring the uncertainty in the model. The hazard intensity is represented by discrete probability distributions, and that resides in the footprint file. Damageability is represented by discrete probability distributions of damage, conditional on every intensity bin, and that sits within the vulnerability file. So both of these things are sampled, as I'll move on to in the next slide. Event uncertainty is not randomly represented or generated in Oasis, because the model developers provide a fixed set of events and a fixed set of event occurrences. But really, the more events that you have, the more scenarios you are exploring in that model. So the more events, the better. And also, in terms of exploring frequency, you might have never seen more than one severe event in history, but that doesn't mean that 2 events can't happen in a year. So if you provide lots and lots of years of event occurrences, where sometimes no events happen, sometimes one event happens, 2, even 3, then that helps you to explore the uncertainty over event frequency. And a final note is that modelers can provide more than one. So you can provide multiple event sets, for example, a historical set and a stochastic set. And also you can provide multiple occurrence files. Perhaps you will consider different clustering assumptions about events. So you can provide multiple sets which have different alternative views of risk associated with them. So, so with that, I just wanted to explain what happens in the kernel. We have on the left the event footprint, which is the distribution of intensity. On the right, we've got the distribution of damage, conditional on each intensity, and that's why you've got multiple charts there. And what we do in the kernel is when an exposure item comes in with a certain area peril and a certain vulnerability, the kernel knows how to join those model files together, and it convolves them. The technical term is a discrete convolution, and that produces a single distribution for every event and for every location, called the effective damage distribution. And we sample that distribution by using random numbers, drawing random numbers, and using them to pick damage percentages in order to generate sampled ground of losses. And the user can specify how many they want to generate. It could be 10, 100, 1,000. And those sampled ground of losses flow through into the financial module, which applies the financial terms and conditions of insurance and reinsurance, and then filters through to the outputs, which are summary loss statistics of all of those losses. So why use Monte Carlo sampling, and what are the alternatives? Well, most models represent some kind of uncertainty, and some platforms combine parameters like means and standard deviations by using some closed form assumptions about what the shape of the distribution is. So that's done sometimes. And also a discrete probability distributions can be convolved if you have some kind of correlation assumption. So that's also a technique that's used by other platforms. But I guess the key reasons for using Monte Carlo is that the loss aggregation is vastly simplified, because we're just having a single loss for every location and we just add them together. It's really easy to understand. It's really easy to produce those loss statistics. Secondly, it replicates the insurance claim process. So when an event happens, you don't have a distribution, you have a single loss. And that's just a single number. So it closely follows that process of event, ground of loss, claim, payout that we're trying to emulate. And thirdly, the financial terms and conditions of insurance and reinsurance are non-linear. So there'll be an excess over which there won't be a payout, and there will be a limit. There'll be a maximum amount that will be paid out in an insurance contract. So non-proportional financial structures. And closed form distributions with means and standard deviations do not well describe these distributions of loss, which may have discontinuities and jumps in them. So Monte Carlo, as long as you've got enough samples, is by far the best way to represent the loss distribution for the insurance and reinsurance financial perspectives. That's all I'm going to say on the kernel, but I do have, I made a 10-minute video on the whole kernel process, including the outputs, and this is the link to it. So if you want to know more about the rationale for the approach and the steps involved, then do take a look at that. So we're nearly finished, and this is all of the links that I mentioned, the resources, The Oasis information library is something we released early this year. It's lots of video tutorials on cat modeling and various perils, on Oasis, on how to install Oasis and all sorts. So that's a good high-level resource. The technical documentation is on the second point. That will very soon include the new key service logic template approach that we've developed. We've got some example toy model repos, repositories, so the Paris windstorm model, which we used as an example, and Pi Wind as well, which is a toy windstorm model in the UK. That's a good place to start if you want to, create a model repository. KTools is the model execution kernel, and that contains documentation for the model data, specification, and conversion. The model development toolkit is the command line Python package for building and testing models. The workshop 2019 is a tutorial on how to use it. So the MDK is very much command line. And so the Jupyter Notebook is a nice browser which takes you through step by step what the commands are. It's quite a nice way to get to know the package. And finally, the Oasis Evaluating Repository. If you're interested in the full platform from the user's perspective, i.e. the UI, you can install the platform and run it as a model user would with example data with a Pi Wind model. Okay, that's everything. So if we have any more time for questions, I'm very happy to take a few more.
Well, one that we deferred, and why don't we just do that one? The stochastic events, where do they come from? Are they generated on historical event sets, or what is the basis?
Yeah, this is a difficult question. It will depend on the peril. Dickie, you might be able to help me with this actually, but there are.
Well, let me just look. I said the point is, we don't define how these things happen, right? So the point is, we allow modelers to say we think this is the best way of doing it. So the example I gave in the chat was on the work we're doing on with Columbia University. They have a statistical model based on HERDAT, and they use that. And then they corrected it for biases. They then had another one which is based on a dynamical model, but that's what they did. Somebody else can do something completely different. I mean, we don't sort of care really, except we like seeing variety and choice and good stuff. So the point is, you can use anything, but you need to justify it, because if it's not good, people will spot it. Was my point. Yeah,
and there's also organisations like the GEM Foundation who provide an open source means of generating earthquake events. So there are tools out there, not many, but that's one of them, which could be considered as an event set generator.
And there's a good question from Josh here, which I might be able to ask the last one. I don't think I can answer this one. Can you, if you read it, it might be easier than if I read it out loud, but it's basically, while you're reading it, just in case anybody can't see the chat, it's about the flexibility to change vulnerability functions without a model rebuild. How can you change the vulnerabilities when a model is already on a platform?
Well, they definitely do have a bespoke approach to modeling. So the method I've described here is the pre-generated model approach. So everything is generated in advance, sits as files on the platform. But this doesn't fit all models. Some models have bespoke modeling techniques that the kernel doesn't support. And so we do have an alternative route, which is called the complex model, where the model provider can plug in code to generate the model on the fly during model execution. And I believe that JBA's global flood model is one of these. So they have a lot more control over generating models on the fly, because that's what
I was just thinking, I mean, technically speaking, you could replace the vulnerability functions with a new set, right? But of course, the issue would be whether or not, for example, the whole model building process is about working out how these things fit together, and does the intensity match in particular between the vulnerability functions and the hazard model. But I mean, in theory, you could just take one out and put one in, can't you?
You can have alternative files, yeah. You can have alternative vulnerability files.
So I think there is a simple way of doing it, which doesn't mean though it's the correct way of doing it, given the fact how models are built generally. I think is my off the top of my head thought. But Josh, that's half an answer to that question. We might need a bit more time on that one and a bit more thought.
Yeah, there's definitely a demand for being able to tweak model files, stress them, add, tune up hazard, tune up vulnerability. That's not something that's easily done with pre-generated files, but I think that might make it onto the features list in the future, Vicky.
Yeah, well, there's one more question which we'll just about squeeze in, which is definitely one for you, I think, from somebody that looks like Elon Musk's new son, because it's coming from I52514. I think that's what his name is. Anyway, can you see that? If I create two models, Wind and Quake for a region, can I now get a combined EP care for my portfolio if I use the Oasis ecosystem?
The Oasis platform is currently a single type of event, so wind or quake. Although within an event you can have multiple perils, but wind and quake are two completely different event sets, of course. You would have to combine the result files manually. So that means generating the sample output and constructing the EP curves by combining them first at the moment. However, with ORD, which is the new open results data standard, that format should make it easier to combine model results.
Good stuff. Well, I think 1 minute early sounds like a great job. Thank you, Joe, and thank you everybody for it's quite a hard format this. We usually do these ones face to face, but when it's a bit more easy, although not necessarily easy for all of you. So thanks everybody for attending. Thank you, Joe. Fantastic job as always. Anything else you want to add, Joe, before we go? Done. Thanks all. Any more questions? Let us know. We're always here. Info or support at Oasis, and have a great afternoon. Bye bye all.